Alright, so a couple chapters ago, we did what was called arithmetic sequences. And in those guys, what were we doing to each term? Either, remember, in order to determine if it was arithmetic or not, they had to be doing what to each term? Adding or subtracting, yep. Okay, so now with geometric sequences, they're going to be multiplying. Okay, so a geometric sequence is a sequence of numbers in which the ratio, which is going to be an R in our formula, stays constant. So basically what that means is that it's either going to be multiplying by the same number over and over and over again, or dividing by the same number over and over and over again. Okay, so we find the common ratio, so found by dividing each term by its previous term. So you're going to need your calculators again, just like usual. Okay, so in number one, is that a geometric sequence? Are they multiplying each time? They are, right? And what are they multiplying by? 5. So our R, so we're going to write R equals 5, because they're multiplying each time by 5. What are they doing in number 2? By what? How are you able to find that? Yeah, you could multiply the other way, or remember you can take the term and divide it by its previous term. So I can go 5 divided by 15, or if I want to do 15 divided by 45, it's always the term divided by the first term. So you guys are telling me that we're dividing by 3, but when we get to our formula, we have to multiply. So dividing by 3 is the same as multiplying by 1/3. Good. Okay. So if they're dividing, they're actually going to be multiplying by that fraction. What are they doing in number 3? They're adding 6. So is this a geometric sequence? It's not. What kind of a sequence is it? Arithmetic sequence, yep. What's going on in number 4? It's going positive to negative, so that means that they're multiplying by a negative, right? Okay, so let's talk about this. So 7 times what gives me negative 14? Negative 2. Negative 14 times negative 2 gives me positive 28, right? Positive 28 times negative 2 gives me negative 56, okay? So if it's switching from positive to negative, what they're doing is they're multiplying by a negative number. Okay? How about number 5? They're doing what? They're dividing by negative 2, which means that my ratio is negative 1/2. Yep, I'm multiplying by negative 1/2. How about number 6? Timesing by what? 4, yeah. Okay, so the only one that wasn't a geometric sequence was number 3. Not too bad, right? Okay, so continuing these, so number 7, what are they doing? Multiplying by negative 3. So in order to continue this, yep, so 63 divided by negative 3? Negative what? No, remember oh yeah, we are multiplying, aren't we? By negative 3. What was it? Negative 189? and then it's a positive 567, and then I gotta take that times negative 3 and get negative 1,700 and what? Take that? Alright. Okay, number 8, what are they doing? Dividing by 4? How'd you get that? Because some people are a little bit confused going, I don't have a clue what's going on in this one. Yeah, so you take 192, so you're going to go 192 divided by 768, and that'll tell you what your ratio, that your ratio is 0.25, right? Okay, so that means we're going to divide by 4. So 192 divided by 4?
48.
Divided by 4? Divided by 4?
3.
Good. All right, so what's happening in 9? Dividing by 2? So what's 2 divided by 2? What's 1 divided by 2? But what am I going to put? 1/2 divided by 2?
1/4.
1/4. Good. Okay, so we get the idea? All right, the moment we've all been waiting for. Okay, so when I'm making my formula, it is a sub n equals a sub 1 times my rate, or my ratio, to the n minus 1. Let's talk a minute about what these things are. A sub 1 stands for what? My first term, just like it did when we were doing arithmetic. And my R, we've learned, is my common ratio. All right, so number 11. Okay, we always start with a sub n. Have to have that written. Equals, what's my first term?
3.
3 times what's happening each one?
3.
We're multiplying by 3, so that's my ratio. And then we say to the n minus 1 power. And now, they want us to find a sub n. So what does that mean that we're going to do? We're going to plug that in for n, right? So 3 times 3 to the what power am I putting it to? To the 6th power, because I have to take my term minus 1. That's what this guy means to do. What that n minus 1 means to do is take the term that you're looking for, n minus 1. Okay, so help me out, 3 to the 6th power. And then we got to multiply by 3. So 2,187 is my 7th term in this. So that's what we're saying. Okay, so number 11, or sorry, number 12, a sub n equals what? Negative 4 times, what are they multiplying by? Negative 5 to the n minus 1. Okay, but they want the formula, so you need to write n minus 1. So on your assignment today, it's got to say n minus 1, and then when you're showing your work, you're going to say a sub 7 is negative 4 times negative 5 to the 6th power. Now be careful in your calculator. That ratio, guys, needs to go in parentheses. Otherwise, it's going to mess up your positives and negatives. So if I need to go negative 5 to the 6th power, and then I can multiply by that negative 4. That makes sense? Because otherwise, if you put it in your calculator without parentheses, you're going to get negative 5 to the 6th power is going to give you a negative. But we know that it's positive because it's to an even power. So this gives us, what, negative 62,500? Right? Alright, let's do a couple more. Let's do one with a fraction. Let's do number 13. What are they doing to each term? They're dividing by 2. So this is going to be a sub n equals, what's my first term?
400.
400. If they're dividing by 2, what are we multiplying by? 1/2 to the n minus 1 power. So on your assignment, this formula needs to be written. And then I think in your assignment it asks for to the a sub 9. But we're going a sub 7. So a sub 7 equals 400 times 1/2 to the 6th power, because we got to subtract 1. So 1/2 has to go in parentheses. 1/2 to the 6th power gives us a crazy decimal times 400 equals 6.25. Are we good? I want to flip that page. We're on the next page. All right. Take a look at that word problem. Okay. So when they want a rule for the depreciation, that's our formula. So a sub n equals, what is this car worth right away? 10,000 times, now what's it doing? How can I find what is happening? We take the one term and divide it by the one in front of it. So 6,400 divided by 8,000, or I could take 8,000 divided by 10,000, right? And what do we get? Okay, so let's talk about this once, because remember we want it as a fraction. So 0.8, how can I make that as a decimal? This 0.8 is written as what? Or is said as what? 8/10. So I can go 8/10, and then what can they both be divided by? Divide them both by 2, and it reduces to 4/5. Boom. So now I've got 4/5 to the n minus 1. Okay, so after 10 years, so a sub 10 equals 10,000 times 4/5 to the 9th. Good. So we gotta go 4/5 to the 9th power times 10,000 gives us, how much is my car going to be worth? $1,342.18. I want that extra penny. It'll rip me off. All right, so is it bad? No, I almost like geometric sequences better than arithmetic. I think they're a little bit easier.